Okay, so what we are going to do is the discharge current experiment to test the discharge capability of E.S.E rod. This is a direct injection surge generator. Refers to 100 ampere electric power injected to the rod. We use a special design clamp to clip the wire on the rod. And this clamp will direct the power back to the negative terminal of the generator. Other than the direct rod injection method, there is also indirect rod injection way, but has high requirement on the rod. Rod injection, in general, is actually an electric conductor, a metal rod with microcircuits and some oscillators inside. Sometimes solar panels and wind panels are also optional due to the usage differences. After power up, an ion excitation effect will be generated in prior of the internal power generation. The rod will indirectly interfere with other internal accessories when conducting current discharge experiment. In this experiment, we will patch in 100 ampere direct discharge to determine the actual interference between the rod and other accessories. Let's run the test through. Let's take a look at the rod after the 100 ampere experiment. Basically, no burning marks on the rod surface, which proves that our tooling and this copper webbing inside are bonding well. Not much room for air clearance. So there is no energy leakage after the power injection. Here are two other comparative experiments. These two rods, one of which is polished to 1 mm on tip diameter, and sharpen the other rod, then we're comparing the rods with different shaped tips to examine the performance of all lightning currents, to check under which tip shape will perform better on our flash experiment. We can assume if the tip was sharper, the surge current would have more impact on it, and then the tip structure would be more fragile. The energy blast damage will also be stronger. Now let's do the test. The test results are as follows. On a flatter rod, you can see scattering burn marks on it. As for the sharpened rod, the tip is heavily blasted by the thunder damage. The tip of it has now become a circular shape, around 2 mm on its diameter. At this point, you can see that over-sharpened tips for a surge rod is not a recommended design. Our tested rod shapes indicates that the considerable variance points hitting in its discharge test could be a good approach for thunder research. Okay, that's the end of this experiment. Thank you for your watching. This video series is presented by Inspection Location, Beijing Lightning Test Lab. Presenter, Chief Engineer Sun Yong. Training rod test from REPSUN Company. English voice actor Liu Zhuo. After all, thank you for your support.